Hello and welcome to Edupedia World. Well, in this tutorial we study about concurrency control. So this is part 1 tutorial of concurrency control. We'll cover two important topics. One is concurrency versus parallelism. Other we'll see few of the concurrency models. We'll cover parallel worker, assembly line, actor versus channel and functional parallelism. Now let's begin. Concurrency versus parallelism. So firstly we see what's concurrency. Concurrency means that an application is making progress or more than one task at the same time concurrently. Well, if a computer only has one CPU, the application may not make progress on more than one task at exactly same time. But more than one task is being processed at same time inside the application. It does not completely finish one task before it begins the next. So this is called concurrency. Okay, then let's go to parallelism. Parallelism means that an application splits its task into smaller subtasks which can be processed in parallel. For instance, on multiple CPU at the exact same time. So you see, in parallelism we are dividing a task into subtasks and then processing them in parallel on multiple CPUs at exactly same time. Whereas when we talk about concurrency, that means we are having one task or more than one task and making the progress of all the tasks at same time, or rather exactly at same time by giving it as data proper quantum of time. It doesn't mean that one task need to finish completely. So all can run in simultaneously, but if one task does not complete one task before it's begin to the next. Okay, now let's see some of the most important concurrency models. Well, concurrency models provide some guidelines or provide some mechanism during which by utilizing them we can achieve the concurrency in our code. So let's see four important concurrency models. First one that we are going to study is parallel worker. So you can see we have delegator and worker in this, and it states that in parallel worker concurrency model, a delegator distributes the incoming job to different workers. Each worker completes the full job. The workers work in parallel, running in different threads and possibly on different CPUs. Many of the concurrency utilities in java.util.concurrent Java package are designed to use with this model. So I hope that you are getting what this model is trying to say. So it basically distributes the incoming job to different workers and each worker complete their job. So each worker is assigned a different job and they complete their job. So this is what parallel worker says. Now let's study another model which is assembly line. So you see in this we have a delegator and worker in a fashion of assembly line. So let's see what it says. The workers are organized like workers at an assembly line in a factory. Each worker only performs a part of full job. When that part is finished, the worker forwards the job to the next worker. Each worker is running in its own thread and shares no state with other workers. This is also sometimes referred to as shared nothing concurrency model. Systems using an assembly line concurrency model are also sometimes called reactive systems or event-driven systems. The system worker reacts to events occurring in the system, either received from outside world or emitted by the other workers. For example, of events could be incoming HTTP request or that a certain file finished loading into memory, etc. So you see everything over here work in an assembly line. So each worker do a specific task from a full-time job. So if it's like a full job, it can be divided into 6 subtasks and each worker do a task such that when job 1 completes or when the part 1 of job 1 completes, then only part 2 will begin and so and so. Node.js actually uses assembly line model for its concurrency control mechanism. Okay, the third one we are going to see is actor versus channel. In actor model, each worker is called an actor. The actor can send message directly to each other. Messages are sent and processed asynchronously. Actor can be used to implement one or more job processing assembly lines as described earlier. Here is a diagram. So you see each worker over here is the actor and they all can interact with each other using sending the messages, and messages are sent and processed asynchronously. Fine. So, and each actor is used to implement one or more jobs. So you can say actor and versus is actually a kind of implementation of assembly line. So assembly line can be worked as either actor or a channel mode. So that was about actor model, and let's see what is it in channel model. In the channel model, workers do not communicate directly with each other. Instead, they publish their messages on different channels. Other workers can then listen for messages on these channels without the sender knowing who is listening. Here is a diagram illustrating the channel model. So you see there are workers, and if they want to interact with each other, they interact through channel by publishing their messages on different channel. So this is the difference between actor and channel. Let's come to another important one, which is functional parallelism. Well, the basic idea of functional parallelism is that you implement your program using function calls. The function can be seen as agent or actors that send messages to each other, just like in the assembly line concurrency model. Okay, that we also called as reactive or event driven system. When one function calls another, that is similar to sending a message. All parameters passed to a function are copied, so no entity outside the receiving function can manipulate the data. This copying is essential to avoid race condition on shared data. This makes the function execution similar to atomic operation. Each function call can be executed independently on any other function call. When each function call can be executed independently, each function call can be executed on separate CPUs. That means that an algorithm implemented functionality can be executed in parallel on multiple CPUs. Now with Java 7, we got java.util.concurrent package that contains fork and join pool. So fork and join pool is a, you can say, mechanism or a class which can help you implement something similar to functional parallelism. And with Java 8, we got parallel streams. So there's a concept of streams in Java 8 which can help you to parallelize the iteration of large collection. Keep in mind that there are developers who are critical for fork and join pool. And the hard part about the functional parallelism is known which function calls to parallelize. Coordinating function calls across CPUs come with an overhead. The unit of work completed by a function needs to be of a certain size to be worth this overhead. If the function calls are very small, attempting to parallelize them actually be slower than the single-threaded single CPU execution. So you see what it's trying to say is to execute the things in parallel way, okay? So each and every function over here is seen as an agent or an actor, just as we seen in a previous, and the messages are sent to each other. Okay, so calling a function means sending a message to like each other. Okay, so function interact with each other by calling them each other. Then again, all parameters of function are copied, so no entity outside receiving function can manipulate the data. So this actually avoids your race condition. And each function call can be also executed separately and can be executed on a different CPU. So, and the implementation for this, well, we'll see when we study Java 8 concepts of streams, and we'll see how actually it's implemented in stream. Okay, as of now, I hope so you got the concept of functional parallelism. Fine, guys. So, guys, we have covered only two topics of concurrency control, when the concurrency control is a big topic. So, this was a part one of the tutorial. We see some of the more topics in part 2 of concurrency control. So let's meet in the next tutorial. Thank you.